All right, so this video is going to be about exponential growth and decay, how we graph, how we get an overview of all the XY combinations, the infinite number of values for X that produce values for Y, and the trajectory. All right, so how fast things are changing. You get a feel from that from a graph. All right, and at the end, I think I said I'd do one problem, one absolute value inequality. So I'll do one of those. All right, so let's take a look at, in general, a b to the x plus c is going to give us one of two types of graphs. Decay, which looks like that, and growth, which looks like that. They have one thing in common. They're both built on some kind of constant. Okay? Either we're growing from something that's minuscule for the longest period of time, almost an infinite amount of time. Something is really, really small, and then eventually it keeps doubling, or tripling, or quadrupling, whatever. Over a period of time, we can define that in infinite number of ways. Or we've got an amount, that big amount that's being cut in half, or a third, or a fourth. Eventually, that amount is dissipating to almost a minuscule amount. So its y values are heading towards a constant. All right, so let's do a decay graph. And let's talk about the four things you have to do to be able to successfully graph a decay problem. So let's start with a number that we can cut in half. Let's put t in here. Now let's stay with x. So let's do x minus 3 over 10, and let's put it on top of, I don't know, 9. Okay, so what's the first thing you look for is the constant. And what you're going to learn is it's going to, if it's less than 1 but positive, it's decay. That's going to be your initial jump. Your initial jump is going to be 40. And then your next jump is going to be cut in half. That looks to be about half. And so that's going to be 20, and then it's going to be in half again. That's 10. If you'll notice, that should be the same amount. And so on and so forth. So how do we find these locations? By making the argument of the function 1 and 0. We'll make it 0 first. What makes that 0? X value of 3. And then we're jumping by 10. We're jumping by 10. These are going to be friendly numbers. And probably going backwards 10, going to be friendly as well. Right? But eventually you need calculators and computers to find all of those numbers in between these friendly integers. These we can use just our noggin for. The numbers in between, for the most part, we need computers and calculators. So what makes 0? A 3. And if I put a 3 in, I get 40, 1/2 to the 0 plus 9. We've been talking about something to the 0 is 1. Well, there's your jump of 40 on top of 9, taking you to 49. And what gave us a 0? 3. That's what you're going to try to learn how to do. What makes this a 1? Because if that's a 1, well, that's not hard. I can take half of 40. Half of 40 is 20. Oh, yeah. 20 on top of 9 is 29. What makes it 1? What makes x minus 3 over 10 1? Well, I hope you say multiply by 10 and add 3. There's our second user-friendly number. So 13 gets us 29. And what I'm suggesting is that if we can see the pattern here, just like you can do 3 points on a line, you've learned how to write 3 points coming out of a linear function, you can pretty much do the same thing here. So there's 49, there's 29. If I add 10, that's 19, and that occurs at 23. Let's just check it real quick. 23 minus 320 divided by 10, 2, 1/2 squared is a fourth. A fourth of 40 is a jump of 10 on top of 9, right? And you can begin to see, oh, that's 20 units of change. Oh, that's 10. Oh, that's going to be 5. Oh, that's going to be 2.5. Oh, that's going to be 40. Oh, that's going to be 80. Right? You can get a feel for what's going on. But all you need is the asymptote and 2 points, and it would be good if you probably got 3 or 4 in the early going, so you can see the trajectory. You can start to see the changes in the table. That's what you're trying to learn how to do. All right, so we're going to do 3 more. You're going to try them by pausing the video, and I'm just going to do the 3. So I'm just going to keep right on going. You got to pause. So what do I see? I look at the base first. I say, wait a minute, that's bigger than 1. I have exponential growth. And then I look at the first number and I go, I'm going to go up 10. And then I'm going to go up 20, which is twice that. That's a pretty good graph right there. 10 and then 20, because that divided by that is why that's 2. So what numbers? I think I'm looking at table values of 3 and 7. 3 and 7 and 11 and 15. I think those are all going to be pretty friendly numbers to me. In fact, I might do them all. All you need to do is the first 2. So what makes a 0? 3. So that gives me 2 to the 0, which is 1 times 10 is 20 plus 8. Oh, I forgot to write y equals 8. I probably should do that very first thing. And that's going to get me 18. And that's going to get me 8 and 20, 28. Provided I use the right numbers, 3 and 7. So I put a 3 in. That gives me 10. 2 to the 0 plus 8. 2 to the 0 is 1. 10 plus 8. Oh, yeah, 18. When I put in a 3, 18. Now, when I put in a 7, I get 7 minus 3 is 4. 4 divided by 4 is 1. Oh, yeah, my first jump was 10. My next jump is 20. And that happened 4 units of elapsed time. And so what's 20? 28 on top of 20 on top of 8, 28. And that happens when x is 7. So that's what I want to see. I want to see the constant. I want to see the exponential growth curve. And I want to see 2 points. 4 things you have to learn. Now, that's the minimal amount of data for this graph. But you can put in more points. Put in 11, and you'll see it's friendly. 11 minus 3, 8. 8 divided by 4 is 2. Well, 2 squared is 4. 4 times 10 is 40. So if that jumps 10, that jumps 20. The next jump is 40. The next jump is 80. The previous jump is 5. The previous jump is 2.5. That's the pattern. I hope you could see that. Yes. Should have moved the computer into a better location, but it was still visible. So we're going to march on. We're going to do Les Miserables, whatever they call it, French national anthem. March on, march on. Anyway, yeah, been doing too much today. I need to take a nap. Here we go. Oh, I see exponential decay. I see decay on top of a 4. That's the first thing I noticed. Oh, and I'm cutting something in half. Why don't I put something there? Why don't I cut it in half? Why don't I cut it in half again? Cut it in half again. Ooh, I'm seeing this. What was that initial amount? Oh, it was 8. Then it's going to be 4. Then it's going to be 2. And it's going to be 1. Oh, boy. If I pick the right numbers. I wonder if I can identify the right numbers here. I think -7 is screaming at me. And I think it's begging me to change it by 9. I think -7 and 2 are going to be very friendly. So when I put -7 in, I get 8 times 1/2 to the 0 plus 4. Ah, 1/2 to the 0 is 1. 8 plus 4 is 12. 8 plus 4 is 12. Yeah. And what number did I pick? Oh, yes, -7. -7 gave me 12. And then 4 plus 4 is 8. Oh, I hate the same numbers showing up anywhere. But anyway, that's going to happen when I put a 2 in. Yeah, and I bet you I get, when I put in another 9 units, that's an 11. 9 plus 2 is 11. I bet I get 6. Yeah, let's put an 11 in, see if we get 6. 11 plus 7. 18 divided by 9, that's 2. 1/2 to the 2 is 1/4 of 8. Yeah, that's 2 plus 4. No, that's what that is, all right. I guess all I needed was those first 2. We'll put a 2 in. 2 plus 7, 9 divided by 9 is 1. Oh, half of 8 is a jump of 4 on top of 4, giving me 8. Boy, it seems to work. Let's do one more over here. Oh, I see growth on top of minus 50. I know what this looks like. Looks like that. And now I am initially going to go up 20 units, provided I pick the right number. Then I'm going to do 3 times that. That's going to be 60. I bet the next one's 180. Woo! Boy, that's growing fast. So what numbers am I going to pick? I see 5 screaming at me, begging to be moved up by 11. I'm going to pick 5 and 16. So 5 is going to get me 20 on top of this, negative 30. And 16 is going to get me positive 10. But let's plug it in and see. 5. 5 minus 5, 0. 3 to the 0, 1. 1 jump at 20. Oh yeah, 1 jump at 20 on top of negative 50 gives me my first data point. Then we're going to pick 11. No, we're going to pick 16. Because 16 minus 5 is 11. And 11 divided by 11 is 1. And 3 times 1 is, 3 times 20 is 60. Minus 50 is 10. And if I see a 15 and a 16 there, I can recreate this. X minus 5 over 11. I can see that now. And so if I put in a number, change by 11, I guess 27 would be nice. Friendly number, 27 minus 5, 22. Yes, 22 divided by 11, 2. Yeah, and 3 squared is 9. And 9 times 20 is a jump of 180. Yeah, boy, that's getting big fast, 180. Minus 50, 130. Yeah, I can even find all kinds of numbers like minus 30, like 10, like, what did we say, 180 minus 50, 130. And I can look at that and I can go, geez, that went up 40 units, right? 10 to 130, that went up 120. You know, that's 3 times that. Okay, so I guess if you can look at an exponential function like the following, y equals the ones out of the textbook might look like 2 to the x plus 7, right? Well, I would hope you would pick 7. I would hope you jump by 10. And I'd hope you jump by 20. And I'd hope you pick the x's that work, 0 and 1. And you'd have yourself a very quick graph of exponential growth. Okay, so what else are you going to learn to do? You're going to learn to go from the graph back to the equation. So we'll give you one practice with that. Let's say that is y equals 7. Let's do growth again. Let's say in 2000, the year 2000, there were 53 sheep. 53 sheep in Gill. But they're growing exponentially because in 2021, there were 109 sheep. These are not friendly numbers, but we can still draw the graph or write the graph very quickly by saying, oh, everything's bigger than 7. Everything's bigger than 7. And the inquiring minds want to know how much bigger than 7. Looks like 46 units is my first jump. Next jump is probably not 46. My next jump is 7 to 109. Well, that's actually 102. And I guess I got to make a table where I scream out the number 2000. X minus 2000. And I look at the change in X, 21 years. Now 102 divided by 46 is somewhere between doubling and tripling. Okay, it's between those two numbers. I'm not doubling, I'm more than doubling the population every 21 years. But with practice, you can write those quickly. And we said we do one absolute value problem where we would do the 3 things. The 3 things. One is the first, well, 4 things, I suppose, I want you to learn how to do. So we'll do all 4. So let's say that we want to graph that. I see a negative sign, so I know it's V-shaped down. I can see -3 screaming at me and 17. Okay, so now what happens when I change the y to an actual number? So let's say this graph equals different y values. Let's say we want it to equal, oh, I don't know. Let me find something that's nice for you. Oh, I didn't finish this yet. Back here. I'm asking you to always give me the y-intercept. So you plug 0 in, and we get -6 plus 17 is 11. All right? So that's one thing you have to learn to do. The other thing you have to learn to do is find out when it equals some other value. So let's say that I wanted to know when it equals 21. How about -10? When does it hit -10? Well, it hits twice, right? It's I had a -10 twice. So that's solving an equation. How do we say we solve that? Well, this is the upside. So I'm going to solve the equation. Yeah, you can see the whole thing. I'm going to solve the equation to, I change the absolute value to a parentheses, x plus 3 plus 17, and I set that to -10. Do I want to do -10? No, I want it to change by 2 to 1. So that's my fault. So let me go down 20 units. I want something that solves nice and easy for you. All right, so let's say we wanted to, I don't want any fractions right now. So let's go down to -9 on both sides, -9. And I'm trying to find that x, and I'm trying to find this x. And that's what we're doing when we solve equations like this. We're finding x values that match up with heights. Okay, so let's find each of these. So now I'm looking at the +2. I'm only going up until I get to this x. I mean, that's the really important x. So I'm only using this branch for numbers that are this side of -3. All right, and I'm looking for -9, and that's a y value. So what do? I subtract 17. And if I subtract 17, I get -26. Slow brain here. Dividing by 2, -13. Subtracting 3, -16. So it looks like I have found this number. I'll check it. -16 plus 3, -13, the absolute value of -13. 13 times -2 is -26 plus 17 is indeed -9. Okay, we're good. Now, it's not cheating, but these numbers are 13 units apart. Okay, this x value, my first x that I found, is 13 units from -3, which means this answer has to also be 13 units. So we're going to get 10. We're going to get 10. But let's make sure by solving it. So we are now going to look at the downside. The downside is -2, x plus 3 plus 17. And we want that to equal -9. So we do the same thing. We subtract 17, -26, that's gone. We divide by -2. In that case, it's +13. That's gone. Then we subtract 3, and it indeed is 10. All right, you can always check to see if your answers are right by taking your answers, two answers, dividing by 2, and the average should be the x value in the middle. And -6 divided by 2 confirms that we have the correct solutions. All right, so we figured out how to solve. We're done with 2 of the problems. Now what happens when we want this thing to be less than -9? How do we do that? Well, we already got our information. We know what the 2 numbers are. They're -16 and they're 10. That's when it equals 0. So we only have 3 intervals, interval A, interval B, and interval C. We know these numbers don't work. They make it equal 0. So they don't work. So we just got to check and see true or false. So we pick a number bigger than 10. I'll pick 1 million. All right, so that's near 2 million. I'm near 2 million. I don't really have to do it all out. Is that number going to be less than -9? Well, of course it is. That's true. And what we've been saying is these alternate. In absolute value, they alternate. Not in other calculations, but in that calculation, it does. We already put a 0 in and got 11, right? We've already done that. A 0 gets 11. Is an 11 less than -9? False, right? Zeros between these, and we got a false. -3's between these. That's 17. 17 is not less than -9. We already got some here that help. Okay, so that's how you solve that. You use sign chart. And you check the interval. So how do I write that answer? We're trying to look at interval notation. So my x's over here, where are these x's? There, we call that negative infinity. Smaller and smaller and smaller. We call this over here positive infinity. All right, so what works? Negative infinity, which cannot be bracketed, to -16, which doesn't work. Union 10, which doesn't work, so parentheses, all the way to infinity. The bigger the number, and I think you can see it here, right? There's a number here. There's a height of -9. This side has y values that are bigger than -9. And below, all of these y values here are lower than -9. All right, that's why we have 10 to infinity. All of these y values come from x values that are smaller than this x. And what is that x? That x is -16. So as I move to the left, I'm looking at -17, -18, -19, and all the numbers in between. Okay, so I hope that gets us started on graphing exponentials. So I'll stop the video, upload it, and we'll tackle those tomorrow.